Imagine this. It's a beautiful Tuesday morning, and a rock the size of a football stadium is about to erase your city from existence. In just 14 days, this space boulder will hit Earth with the force of 4,000 nuclear bombs. The fireball will be brighter than the sun. The shockwave will flatten everything for hundreds of kilometers. And here's the terrifying part. We have no real plan for this. This isn't science fiction. In 2019, an asteroid the size of a 10-story building was discovered just one day before it passed closer than some satellites. Last year, an even bigger one was spotted only 13 days before grazing us with the power of 9,000 Hiroshima bombs. Scientists have proposed painting asteroids, attaching thrusters, or ramming spacecraft into them. But this is like trying to stop a cargo ship by throwing a potato at it. These methods work only if you have decades of warning. But recently, scientists discovered something incredible. A brand new method to obliterate killer asteroids using technology we already have. Let's test it on our 100-meter death rock heading straight for us. First, you need to understand what asteroids really are. Most asteroids aren't solid rocks. They're more like bags of loosely packed gravel, barely held together by gravity. Which means instead of nudging them, we can smash them to dust. And the obvious choice? A nuclear bomb. So let's load up a warhead, launch it, and... oh, the asteroid just destroyed our nuke. Asteroids approach at 70,000 kilometers per hour, fast enough to cross the Atlantic in 5 minutes. No bomb can survive that impact. Okay, let's explode it before it touches the asteroid. Sad boom. A dramatic crater appears and nothing else. In space, there's no air to carry a shockwave. Most of the energy is wasted. Fine, let's go Hollywood. Land astronauts, drill a hole, bury the nuke inside. This could work in theory, but practically, even on Mars, 70% of landing attempts fail. And drilling in zero gravity is painfully slow. We don't have the time. So forget Hollywood. We need to think like a lumberjack. If you want to split a log, you don't throw rocks, you use an axe. Meet the Penetrator, a few meters long, made of tungsten, way denser and harder than any rock. And here's the genius part. We don't even shoot them. We just place them in the asteroid's path. From the asteroid's perspective, they're rushing at it at 70,000 kilometers per hour. But the hardest part is getting there in time. We need to intercept it 1 day before impact. That's nearly 2 million kilometers away, more than 4 times the moon's distance. Our current rockets can cover this in about a week. We send one Penetrator, 2 meters long, 2.5 tons. We position it perfectly and wait. A tiny speck of light appears, and then suddenly it's here. Let's slow down time. The asteroid crashes into the Penetrator with unimaginable violence. The impact releases 120 tons of TNT equivalent. Rock vaporizes, tungsten melts, a wound tunnels deep through the asteroid. The asteroid can't hold together. It blasts apart into thousands of pieces. The debris spreads into a diffuse cloud across hundreds of thousands of square kilometers. A day later, the fragments hit Earth's atmosphere harmlessly. An apocalypse becomes a beautiful cosmic fireworks show. But this was just a small asteroid. What about a planet killer? The dinosaurs would tell you about planet killers, but they're dead. The most dangerous are comets from the outer solar system, so dark they're nearly impossible to track. In 2020, Comet NEOWISE, carrying 6,000 times the power of every nuclear bomb, was discovered just 4 months before its closest approach. Imagine we spot such a monster 6 months before impact. Do we stand a chance? Unfortunately, it's extremely hard. A planet killer has so much more mass. Breaking it into millions of pieces won't help. The chunks would still set the sky on fire. We need to destroy it as far away as Mars, and we'd need hundreds of thousands of penetrators. That requires 24,000 super heavy rockets. Humanity currently has 2, and they're not even finished. If we discovered a planet killer today, there's literally nothing we could do. Except maybe if we combine penetrators with nuclear bombs. For this to work, we need everything ready beforehand. A fully loaded rocket on standby, something like NASA's Sekunde prepped for the worst day in human history. The moment it's spotted, we launch. 5 months of travel through the void while Earth waits nervously. Finally, it reaches beyond Mars' orbit. Now we deploy 5 massive penetrators in perfect sequence, 2 kilometers apart. Brave astronauts supervise this suicide mission. There's no way home. All of humanity watches. And then, the icy mountain appears. Slow down time. First impact, 140,000 kilometers per hour, 2,000 tons of TNT. Second, third, fourth, each drilling deeper. And then the final penetrator, 300 megatons, 20,000 times Hiroshima. It travels deep into the tunnel and detonates. This time it works. The explosion hits rock, ice, and gravel. A frozen world billions of years old dies from within. It shatters into millions of fragments. Humanity is saved. Making this real would require unprecedented planning and precision. And yet, it's possible. Not in a century, but with technology we already have today. The universe throws mountains at us. We're tiny creatures on a fragile blue dot. But we're also the only creatures capable of defending our home. That asteroid hurtling at impossible speed, we can turn it into a light show. For a species that only recently figured out how to leave the ground, what we are doing is absurdly ambitious. In just over a century, we went from fragile wooden planes hopping over fields to metal tubes routinely crossing oceans at nearly the speed of sound. Then we pointed those machines straight up and left the planet entirely. Now the same clever, anxious primates that once feared thunderstorms are calculating how to intercept mountains of rock moving faster than bullet. We map their orbits, design tools dense enough to punch through them, and seriously discuss plans to blow them apart before they blow us apart. All of this from brains that evolved to throw stones, not to deflect asteroids. So yes, turning a planet-killing rock into a harmless light show in the sky is more than just clever engineering. It is a quiet reminder that, for a species that only learned to fly about 100 years ago, we are already trying very hard not to fall.